Hello everyone, I hope you are doing well. In today's video, we are going to work through a test for review worksheet. We will cover the major topics you should know before your test, including indefinite and definite integrals, the fundamental theorem of calculus, Riemann sums, initial value problems, area of graphs, properties of definite integrals. I encourage you to pause the video and try each problem before watching the solution. Let's get started. Question 1. We are going to evaluate the following integrals. So, in this problem, we will review basic antiderivative techniques. Before integrating, notice that each term can be integrated separately. Therefore, for part A, we will have indefinite integral of 3 to x dx plus integral 5 divided by x dx minus integral 7 divided by 1x squared dx plus integral 4 times sine of x dx, which would be equal to integral 3 to x dx. Because 5 is a coefficient, you can consider the second and third and fourth integrals as 5 integral dx divided by x minus 7 integral dx divided by 1 plus x squared plus 4 times integral sine of x dx. So now the antiderivative of 3 to x by using the formula that you learned would be 3 to x divided by ln of 3 plus 5. Antiderivative of 1 divided by x would be ln of absolute value of x minus 7 times antiderivative of 1 divided by 1 plus x squared would be arctangent of x plus 4 times antiderivative of sine would be negative cosine of x plus c. So therefore the final answer would be 3 to x ln of 3 plus 5 ln of absolute value of x minus 7 arctangent of x minus 4 cosine of x plus c. Therefore we could answer part A. So for part B, we need to simplify integrand first, and then by using the rules that you learn, we can evaluate indefinite integral. So now let's simplify integrand before integrating. So look at the first one. Look at first one. So for first function, you can consider a square root of x as x to 1/2, and then you can consider x cubed plus 1 divided by x to 1/2 as x cubed plus 1 times x to negative 1/2. Plus, you can separate this quotient as multiplication, like this. You can consider this quotient as 1 divided by sine of x times cosecant of x plus cotangent of x plus sine of x. Be careful that you need to use parentheses in this case. So now, by using the distributive property, you can rewrite the first function as x2 3 minus 1/2 plus x2 negative 1/2 plus 1 divided by sine of x would be cosecant of x. Cosecant of x multiplied by cosecant of x plus cotangent of x plus sine of x dx. So therefore we will get x2 5 divided by 2 plus x2 negative 1/2 plus, again, by using the distributive property, you can rewrite this expression as cosecant square of x plus cosecant of x times cotangent of x plus cosecant of x times sine of x. Because cosecant is 1 divided by sine, you can cancel sine from top and bottom and you will get 1 dx. So now we can separate this indefinite integral and we can find antiderivative of each function separately. So therefore we will get definite integral of x to 5 divided by 2 dx plus integral of x to negative 1/2 dx plus integral of cosecant square of x dx plus integral of cosecant of x times cotangent of x dx plus integral of dx, which is equal to, so for first function, because you have power function, by using power formula for antiderivative of x to 5 divided by 2 would be x2, we will add 1 to exponent and we will divide by new exponent, 5 divided by 2 plus 1 plus x to negative 1/2, antiderivative of x to negative 1/2 would be x to negative 1/2 plus 1 divided by negative 1/2 plus 1. Antiderivative of cosecant square of x would be negative cotangent of x, because derivative of cotangent, negative cotangent, would be cosecant square. Antiderivative of cosecant times cotangent would be negative cosecant of x plus antiderivative of 1 times dx means antiderivative of 1 would be x plus c. So now you just need to rewrite and you just need to do some algebraic steps. So this would be x to 7 divided by 2 divided by 7 divided by 2 plus x to 1/2 divided by 1/2 minus cotangent of x minus cosecant of x plus c. And you will be done. So now we are gonna evaluate this definite integral. So to evaluate this definite integral, as you can see, because we have a composite function in the denominator, we can think about u-substitution method. So therefore, we can consider u as 1 plus x to the 4. And by taking derivative of u with respect to x, we will try to rewrite this integral, which is in terms of x, as another integral that would be in terms of u. So to start, we need to take derivative of u with respect to x. Du dx would be 4x cubed. So from here, du would be 4x cubed dx. Therefore, if you divide each side by 4, du divided by 4 would be x cubed dx. So now look at this. We will try to rewrite this definite integral as another definite integral that the variable of integration would be u. Instead of x cubed times dx, we can consider du divided by 4. du divided by 4. Instead of 1 plus x to the 4, we can consider u. So would be u squared. But what about the bounds? We must change the bounds as well. So we need to change bounds. So lower bound is 0. The new lower bound would be u at 0, which is 1 plus 0, which is 1. So therefore, the lower bound would be 1. Upper bound is 2. Therefore, the new upper bound would be u at 4. u at 4 would be 1 plus 2 to the 4th, which is 17. So therefore, this definite integral can be considered as another definite integral in terms of u. Now, we just need to solve the new definite integral, which is in terms of u. So you can consider numerator as 1 divided by 4 du, all divided by u square. And then you can consider 1 divided by 4 as a coefficient. Therefore, by using constant multiple rule, you can rewrite this definite integral as 1 divided by 4, definite integral from 1 to 17, du divided by u square. So now to evaluate this definite integral, you can consider 1 divided by u square as u to negative 2 by using negative exponent formula. So therefore, you can rewrite this definite integral as u to negative 2 du. And now by using power formula for antiderivative, we can find antiderivative of u to negative 2. So you have 1 divided by 4. Antiderivative of u to negative 2 would be u to negative 2 plus 1 divided by negative 2 plus 1. And by using FTC part 2, you must evaluate this one from 1 to 17. So therefore, the answer would be 1 divided by 4 u to negative 1 divided by negative 1 from 1 to 17. That would be negative 1 divided by 4, 1 divided by u from 1 to 17, which is negative 1 divided by 4, 1 divided by 17 minus 1 divided by 1. That would be negative 1 divided by 4 times negative 16 divided by 17, which is, you can cancel 4 from top and bottom. Therefore, the final answer would be 4 divided by 17. So therefore, we could answer this question using u-substitution method. So now we are going to solve question 2. Question 2 says, suppose capital F is integral from square root of x squared plus 4 to 3 of t cubed sine of 1 plus t dt. We are going to compute capital F prime. So for this question, we must use the fundamental theorem of calculus part 1. So, because as you remember, when we have a function in integral form, to find derivative of that function, we must use FTC part 1. But to use FTC part 1, we need to make sure our integrand is a continuous function. So, in this case, f of t, which is t squared sine of 1 plus t, is continuous everywhere. So, therefore, f of t, or our integrand, is continuous everywhere. And also, we learn when capital F of x would be a function like this, integral of a to gx f of t dt, then derivative of this function would be f of g of x times g prime of x. So, therefore, when we are gonna find derivative of capital F in our problem, in our problem, capital F of x is integral from square root of x square plus 4 to 3 t square sine of 1 plus t dt. So in this case, we must change the bounds because in general form, lower bound is a number, upper bound can be as a function. So therefore, if you are going to use this formula, you need to make sure lower bound is a number, upper bound is a function. Therefore, by using the property of integral, you can change the bounds and make the integral negative. So therefore, this integral would be negative integral from 3 to square root of x square plus 4 t square sine of 1 plus t dt. So therefore, capital F prime of x would be negative. We need to find derivative of this function. Derivative of this function by using the formula that we have would be f of square root of x square plus 4 times derivative of x square plus 4. So, which would be equal to f at square root of x square plus 4. This is f. This is function f. So, you need to plug x square plus 4 for t. Therefore, f at x square root of x square plus 4 would be x square plus 4 times sine of 1 plus square root of x square plus 4 times derivative of square root of x square plus 4. So we can find derivative of x square plus 4 separately. Derivative of square root of x square plus 4. You can consider square root of x square plus 4 as x square plus 4 to 1/2. And then by using chain rule, derivative of this function would be 1/2 x square plus 4 to negative 1/2 times 2x, which is equal to x divided by square root of x square plus 4. Because you can cancel 2 from top and bottom, and by using negative exponent rule, you can consider x square plus 4 to negative 1/2 as 1 divided by square root of x square plus 4 times x would be x divided by square root of x square plus 4. So therefore, derivative of x square plus square root of x square plus 4 is x divided by square root of x square plus 4. We have a negative sign here, therefore we could answer this question as well. We found derivative of our function. So therefore, for this question, you need to memorize this formula. So now we are gonna solve question 3. So to solve question 3 says consider the element of sigma from I from 1 to n, a divided by n square root of 25 minus 2 plus 8 I divided by n square, and represent this limit as definite integral. So because we learned definite integral would be limit of Riemann sum, therefore we know relationship between definite integral and limit of Riemann sum, which is like this. Definite integral from a to b f of x dx is equal to limit of sigma from I to n f of xi star delta x n approaches infinity. So means limit at infinity of Riemann sum would be definite integral of a function from a to b. So therefore, if you compare this limit with limit of Riemann sum as n approaches infinity in general, means if you compare this limit with this formula, you can conclude delta x would be 8 divided by n. So delta x would be 8 divided by n. And also f of xi star would be a square root of 25 minus 2 plus 8 times I divided by n square. You can assume that you are using right Riemann sum. Therefore, if you are using right Riemann sum, this means f of xi would be a square root of 25 minus 2 plus 8i divided by n square. So now to represent this limit as definite integral, we need to find a, b, and f of x. So to find a and b, because we have a formula for delta x would be b minus a divided by n. In our problem, delta x is 8 divided by n. Therefore, you can conclude b minus a is equal to 8. So therefore, b would be a plus 8. So therefore, the interval ab would be like this, a plus 8. Therefore, in this step, we need to find a. To find a, because we know a formula for xi is a plus I delta x. So therefore, xi in our problem would be a plus I delta x is 8 divided by n. Would be a plus 8i divided by n. So xi in our problem would be a plus 8i divided by n. Also, because f of xi is a square root of 25 minus parenthesis 2 plus 8i divided by n, you can conclude from here that this part would be xi. So therefore xi would be 2 plus 8i divided by n. So therefore we have xi as 2 plus 8i divided by n. So now if you compare this one with this one, you can conclude a is 2. So when a is 2, the interval that was a plus 8 would be 2 to 10. So therefore you could find the interval. Now because f of xi is a square root of 25 minus xi square, because we consider 2 plus 8i divided by n as xi. Therefore f of xi would be 25 minus xi square. So therefore f of x would be a square root of 25 minus x square. When f of xi is 25, a square root of 25 minus xi square, you can conclude f of x is a square root of 25 minus x square. So therefore you could find f of x and you could find the interval ab. Therefore this limit as remains as definite integral would be definite integral from 2 to 10 a square root of f of x is a square root of 25 minus x square dx. So therefore you could rewrite this limit as definite integral. So now we are going to solve question 4. Question 4 is initial value problem. So to solve this question, you need to use the concept of antiderivative. So therefore here we have a second order differential equation with initial conditions. These two are initial conditions, these two. And we will integrate twice. We will integrate twice to find f of x. And we will apply initial conditions to find constant c sub 1, c sub 2. So let's see. When f double prime of x is 6 e to 2x minus 3 cosine of x plus 8x cubed minus 5, to find f prime of x, you must take integral. So, or you must take antiderivative. If you find antiderivative of this function, antiderivative of this function would be f prime of x. So, therefore, f prime of x would be integral 6 e to 2x minus 3 cosine of x plus 8x cubed minus 5 dx. So, which is equal to 6 integral e to 2x dx minus 3 integral cosine of x dx plus 8 integral x cubed dx minus 5 integral dx, which is equal to find this integral, you need to use u-substitution method. Let's do this one separately. Let's do this one here. So, to find integral e to 2x dx, we must use u-substitution method because you have a composite function. You can consider u as inside function 2x, and by taking derivative of u with respect to x, you must rewrite integral as another integral in terms of u. So, if you take derivative of u with respect to x, du dx would be 2. Therefore, du would be 2 dx. Or if you divide each side by 2, du divided by 2 would be dx. So, therefore, instead of dx, you can consider du divided by 2. Instead of 2x, you can consider u. So, therefore, this integral would be e to u du divided by 2, which is 1/2 integral e to u du, which is 1/2 integral e to u du would be e to u, because antiderivative of e to u would be itself with respect to u plus c. So, therefore, by using u-substitution method, antiderivative of first function would be e to u 1/2 times e to u, but you must back to original variable. Instead of u, you must consider 2x, e to 2x. So, therefore, for first integral, the answer for first integral would be 1/2 e to 2x minus 3. Antiderivative of cosine would be sine, because derivative of sine is cosine, plus 8 times antiderivative of x cubed would be x to the 4 divided by 4 minus 5 antiderivative of 1 is x plus c sub 1. So, therefore, f prime of x would be 3 e to 2x minus 3 sine of x plus 2x to the 4 minus 5x plus c sub 1. Now, if you find antiderivative of f prime of x, or if you take indefinite integral from both sides, you can find f of x. So, therefore, f of x would be integral of 3 e to 2x minus 3 sine of x plus 2x to the 4 minus 5x plus c1 dx, which is equal to 3 integral e to 2x dx minus 3 integral sine of x dx plus integral 2 integral x to the 4 dx minus 5 integral x dx plus integral c1 dx or c1 integral dx. So, which is equal to 3 integral e to 2x, we already found this integral, would be 1/2 e to 2x. So, 1/2 e to 2x minus 3. Antiderivative of sine would be negative cosine. You have a negative sign here, so therefore would be positive. 3 cosine of x. Plus 2 antiderivative of x to the fourth would be x to the 5 divided by 5. Minus 5 antiderivative of x would be x squared divided by 2 plus antiderivative of c1 would be c1x plus c sub 2. So, therefore, we will get 3 divided by 2 e to 2x plus 3 cosine of x plus 2 divided by 5 x to the 5 minus 5 divided by 2 x squared plus c1x plus c2. So, this would be f of x. This is f of x and this is f prime of x. So, now we just need to find c1 and c2 by using the conditions that we have. We know f prime at 0 is negative 1. Look at this. This is f prime. This is f prime. This is f prime. So, we know f prime at 0 is negative 1. F prime at 0 is negative 1. Therefore, if you plug 0 for x, you must get negative 1. So, therefore, negative 1 would be equal to 3 e to 0 minus 3 sine of 0 plus 0 minus 0 plus c1. Sine of 0 is 0. Therefore, negative 1 is equal to 3 e to 0 is 1 plus c1. From here, you can find c1. So, therefore, c1 would be negative 1 minus 3, which is negative 4. So, therefore, c1 is negative 4. Now, we know f at 0 is 2. We know f at 0 is 2. And also, we know f of x is equal to this function. F of x is this function. F of x is this function. So, now, because f at 0 is 2 and also c1 is negative 4, therefore, if you plug 0 for x in f of x, you will get 2 is equal to 3 divided by 2 e to 0 plus 3 cosine of 0 plus 2 divided by 5 times 0 minus 5 divided by 2 times 0 plus c1 is negative 4. Negative 4 times 0 plus c2. So therefore 2 would be equal to e to 0 is 1, 3 divided by 2 plus cosine of 0 is 1 plus 3. This is 0, this would be 0, this would be 0 plus c2. So therefore 2 is equal to 9 divided by 2 plus c2. So from this equation, you can find c2. c2 would be 2 minus 9 divided by 2, which is equal to negative 5 divided by 2. So therefore, this would be c2. Now, we found c1 and c2. Therefore, f of x, which is this function, would be 3 divided by 2 e to 2x plus 3 cosine of x plus 2 divided by 5 x to the 5 minus 5 divided by 2x squared minus c1 is negative 4. Negative 4x, c2 is negative 5 divided by 2. And this would be f of x. So therefore, we could find f of x as well by using initial value problem. So now, for the last question, we have graph of f of x, and by using this graph, we are gonna evaluate this definite integral. So we learn definite integral would be net area. If our function be positive, definite integral would be area. If our function takes positive and negative on a given interval, definite integral would be net area. So therefore, look at this. To evaluate this definite integral from negative 4 to 8, first of all, by using the property of definite integral, you can rewrite this definite integral as definite integral from negative 4 to 8 f of x dx minus 5 definite integral from negative 4 to 8 dx. Or you can consider this one as negative definite integral from negative 4 to 8 5 dx. So, which is equal to 2 definite integral from negative 4 to 8 f of x dx minus this definite integral of constant function by using the formula that you learned would be that constant, in this case 5, times the length of interval 8 minus 4, which is plus 4. So therefore, we will get 2 times definite integral from negative 4 to 8 f of x dx minus 8 plus 4 would be 12 times 5 would be 60 minus 60. So therefore, to complete our answer, we just need to find this definite integral. This definite integral would be net area from negative 4 to 8. So negative 4 to 8. We need to find this area from negative 4 to 8. So therefore would be, if you name this one A1, A2, A3, A4, A5, A6, A7. So definite integral from negative 4 to 8 f of x dx would be A1 plus A2 plus A3 plus A4 minus A5 plus A6 plus A7, which is A1 plus A2 plus A3 plus A4 minus A5 minus A6 minus A7. So therefore we just need to find area of triangle, rectangle, and semicircle that we have. So A1 would be 1/2 times 2 times 2, which is 2. A2 would be 4 times 2, which is 8. A3 would be 1/2 times 1 times 2, which is 1. A4 would be 1/2 pi, or in this case, r would be 1 square. So therefore would be pi divided by 2. A5 would be 1/2 times 1 times 2, which is 1. A6 would be 2 times 2, which is 4. And A7 is 1/2 times 1 times 2, which is 1. So therefore net area in this case would be 2 plus 8, 10, 10 plus 1, 11, 11 plus pi divided by 2, 11 plus pi divided by 2, minus 6, which is 5 plus pi divided by 2. Therefore we could find definite integral from negative 4 to 8 f of x dx. Now the final answer would be 2 times 5 plus pi divided by 2 minus 60, which is 10 plus pi minus 60, which is pi minus 50. So the final answer would be pi minus 50.